discuss is something called the mean value theorem, and this isn't like the not nice theorem, because this is math. We're not talking about like the angry theorem. What do you think mean will mean in this case?
Average.
Yeah. So some kind of average value theorem. So before we talk about that theorem, we're going to talk about an easy case it. Oh, that's not your class. That's something different. Okay. So the first thing is something called Rolles Theorem, which is technically a special case of the mean value theorem. Okay, so you have a function, and suppose your function is continuous on the closed interval from a to b and differentiable on the open interval. And then f of a equals f of b. What does that mean? What's true about the y values at the endpoints? They're the same. So the same y values. And the continuous means you have no breaks. The differentiable means you can't have any corners, right? Okay. Then there is a number c in between a and b where the derivative is 0. Okay, so you have some a, you have some b. Here's a picture of why it works. The y values there are equal. Okay, pretend that I can draw those at equal heights. So if you're continuous, you've got to go from a to b in one like smooth swoop, right? If you're differentiable, you can't go there with any points. So you could do something like this. And then is it true that the derivative is 0 someplace in the middle? Yeah, there would be the point c. And at that point, f prime of c is equal to 0. Does this theorem say there's only one point?
No.
No. Could there be more than one point?
Yes.
Yeah, suppose I had a function like that. Does that make sense? There'd be 2 points where that derivative was 0. This just says that there is at least one. So there could be one or more. What if I connected those dots with a horizontal line? Is it still true? The derivative is 0 everywhere. Now there's an infinite number of places where the derivative is 0. And
Could you remind me, when is something not differential?
when there's a corner,
That'd be like absolute value.
like an absolute value type thing,
Mm-hmm.
and in that case, the theorem breaks. And it isn't really that the theorem breaks, it's just the theorem is not true if condition number 2 is not true, right? So condition number 2 must be met for the theorem to even apply in the first place. If those conditions are not met, then all bets are off, okay? So all this is saying is if a function is continuous and differentiable and the y values at the ends are equal, then there has to be a c where the derivative is 0. Which is basically saying there has to be a horizontal tangent line, right? Okay, so this thing says to verify that this function satisfies 3 hypotheses on -2, 0, and then find all numbers c that satisfy the conclusion. So hypothesis number 1 is that f of x must be continuous on -2, 0. This is true because f is a what?
Cubic.
Yeah, f is a, I was going to say polynomial. Because it's not just a cubic. You guys know polynomials are continuous, right? And then the next condition is f of x must be differentiable on open interval. True, same reason as number 1. And what's the final thing you have to check?
That -2, or that f of -2 is that 0?
So f of 0 is super easy to work out, right?
1.
That's 1. F of -2 will be -8 plus 4 plus 4 plus 1 also equals 1. Okay, so once you know those things are met, so you did the whole verifying thing, the next part says find all numbers c that satisfy the conclusion. We want to find where f prime of c is equal to 0. That's the conclusion. Is f prime of c in essence any different than f prime of x? Like, really?
No.
It's just the derivative with c plugged in instead of x, right? So what is the derivative?
3x squared plus 2x minus 2.
Yeah, I'm just gonna use c's, but yeah, 3c squared plus 2c minus 2 equals 0. And that doesn't factor. So what do you have to use? You have your favorite formula. It'd be c equals, oh, that's bad. Let me use c 2 places. Let's use x's. I take back what I said. F prime of x. So x equals negative b plus or minus square root b squared minus 4ac all over 2a.
Why did you try using c in the first place when the function was f of x all along?
Because it said find the numbers c, which means they want it to be c equals. I mean, it doesn't really matter. It doesn't matter what letter is there. It's going to be the same conclusion, so it's not really all that important.
We're only looking for real numbers, right?
Mm-hmm. Only looking for real numbers. I think that they're both, but the thing is they're either both going to be real or they're both going to be imaginary. And since you know it has to happen, you know you're going to have to get real answers. Does that make sense? Like, because this theorem guarantees they're going to occur, and you're going to actually have two of them. So you have negative 2 plus or minus the square root of 4 minus 4 times 3 times negative 2 all over 6. Do you agree? Okay, so that's x equals negative 2 plus or minus the square root of, okay. Does that root simplify at all? 2 root 7 is what we said? And then can you simplify some more? Okay. Is everyone okay with how that went? Now, the one tricky thing about these problems is your answer must be in the interval from negative 2 to 0, or whatever interval that you're given. So 7, root 7, you don't know it exactly, but is it bigger than 1? Yeah. So is negative 1 plus root 7 a positive or negative number? Positive. So will that be within this interval? Not from negative 2 to 0. Because negative 1 plus root 7 is going to be positive. A positive over a positive 3 makes a positive. A positive's outside that interval from negative 2 to 0. So the only answer is negative 1 minus root 7 over 3. One thing you could do to see if you were right is you could graph your function, like with a graphing something or other, on that interval and see how many turnaround points are there actually in that little subinterval. So does the function turn around once or twice? Or you could take a calculator and just guess to actually get an estimate for what root 7 was.
Twice, it means we'd have 2 answers in there?
It means you'd have 2 answers in there, yep. So like if you had a picture and you graphed it from negative 2 to 0, over there, and it did something like, I don't know, that, then you would have 2 answers, right? But if it does something like, I'll pretend that was equal, that'd be only 1. So that'd be one way to check and see how many answers you're going to have. Okay. And you can use this idea to show that equations like this have only one answer. So these are always going to follow sort of a certain set of steps. I'm going to show you the set of steps. So step 1 is to show, well, make a function. We did this last time, right? I said every proof begins with let. That's kind of step 0, because you start counting from 0 in math classes. Step 1 is use the IVT to show a root exists. We did that back in section, I think it was 2-5, if you want to go back and look at your notes to see what that said.
What's IVT mean?
So IVT stands for Intermediate Value Theorem. So this is the thing where we like plugged in one number for f and plugged in another number for f and found that one was positive and one was negative, and then therefore there was a 0 in the middle. So if you plug in 0, does it make sense you get -1? Okay. Now I need another number that when I plug it in, I get a positive answer. 1. Yep, f of 1 is going to equal 1, right? And so thus you know that f of x equals 0 in the interval from 0 to 1 at least once. And the picture for that is that when you plug in 0, you get a negative number. When you plug in 1, you get a positive number. Function must cross someplace. But nothing says it doesn't cross twice. Yeah.
Do you mean it equals 0 in, oh,
No, I do mean 0 to 1. What?
Well, you said nothing says it doesn't cross twice, or that only, that it's at least once, but it says it has, it wants you to prove it has exactly one.
Uh-huh. I'm not done yet.
Okay.
Yep. Okay. All right, so does everybody agree that there is at least 1 0? Okay. So step 3 is to show there is only 1. And you're going to use a method called contradiction. It's a little bit like lawyering. I don't know what happened to it. I skipped it because I'm not counting logical. That's step 2. Okay, contradiction. Okay, so so does it make sense that if I show there can't be 2, there can't be 3, and there can't be 4, and there can't be 5? As in, if I show this thing can't be 0 twice, it can't be 0 3 times either, right? Because if it was 0 3 times, it'd be 0 twice as well, right? So what we're going to do is we're going to assume f of x has 2 zeros in the interval from 0 to 1, and do I know where they are? You gotta give them the names. We're gonna call them A and B, just because. Okay, if they're zeros, does it make sense that when you plug them in, what do you get for both of them?
0.
If they're both zeros, when you plug them in, you get 0, right? And f of x is continuous and differentiable because it's a polynomial. We're going to apply Rolles Theorem. Do you agree that all the conditions are met? Yeah, is it continuous, differentiable, equal? And specifically on the interval from A to B. And A and B are those 2 zeros I speculate occur, but don't know for sure.
so you just, this is the way to like check and see what you know.
So if you apply the Rolles theorem on the interval, then f prime of x will have to equal 0 in the interval from A to B. And here's where the problem's going to happen. Or what is f prime of x equal to in this case? You don't know? Look at the step 0. Look at the function. What's the derivative of a function? 3x squared plus 1 equals 0. in AB. Is that a problem? Or, yeah, so that, I claim that's a problem. Can 3x squared plus 1 equal 0 for any real numbers? If you solve that, what kind of answers are you gonna get?
Plus one.
What's it called when you get i's and things? They're called imaginary answers. Okay, so this is what's called a contradiction. And what this means is your original assumption was false. The thing that led you to this being the conclusion has to be wrong. So what is the thing that was wrong?
At least.
There's 2 zeros.
Yeah, so which means thus f of x cannot have 2 zeros. And it must have only one.
Was it just for this example, or did we have some reason to assume that f of x had 2 zeros?
The way that these are always going to work is you're always going to assume that there's one more than you claim that there exists. It's like if you were trying to prove that there were only 2 zeros, you'd assume that there were 3 and something that was bad would happen. But I'm going to keep them pretty simple. They're going to be more or less like this. But let's just run through what happened there. So you assume it has 2 zeros. That part's not very hard, right? You just say, I think it's going to have 2 zeros, and then they're going to have some variable letters. I don't know what they are, but they exist. And then you say, because they're zeros, you know that when you plug them in, you get 0, right? And then you apply Rolles theorem, and your derivative is something that can't be 0. And because the result of that assumption yields something that is not true, your original assumption was incorrect. It's a bit lawyer-like, isn't it? Well, if this was happened, then this would have happened, and then that would have happened, and that's not possible. So the first thing was, wrong. Okay, let's try another one, because they all follow a similar pattern. And it should be pretty obvious that your derivative is something that will not be 0. Okay, so we start by making a polynomial. So step 0. So what's my function going to equal? Next is to use the IVT. Okay, so well, f of 0 is 3. Is there a number that you can plug in to get a negative value?
-1.
Yep. F of -1 is going to be -11 plus 3, -8. Do you buy that? And thus f of x will have to equal 0 in what interval? Almost. -1 to 0. And we probably should add since f of x is continuous, right? I mean, we did need that. I made you put that in your test. Okay, and then comes the hard step. Next, you assume there are 2 zeros in -1 to 0. Call them A and B.
Is that all right if we write all of this in the proofs?
Yeah. And then f of A equals f of B, and what does that equal? And actually, I realize I'm adding something in that doesn't need to be there. They don't need to be in -1 to 0. There can just be, like, they can be anywhere. So that's not necessary. There are just two zeros, you call them A and B. And when you plug them into the function, you get 0, right? And since f of x is continuous and differentiable, because it's a polynomial, you can apply Rolles theorem. So f prime of x will need to equal 0 somewhere in the interval from a to b. Or, what is the derivative in this case? And is it pretty obvious that that's not possible? Think about 5x to the fourth plus 10. You plug in positive numbers, you get a positive result, right? You plug in negative numbers, you get a positive result, right? What's the smallest 5x to the fourth plus 10 is going to be? 10. It's a quartic, fourth power thing, shifted up 10, right? It's never going to be 0. This is a contradiction. And thus f of x has only 1 0.
Killing that chord extremes.
Say what?
You're killing the chord extremes.
Oh,
What if
sure.
it wants to be 0?
That just doesn't get to be. And one nice thing this can do for you is that if you say we're looking at a graph of this function, and you see that it crosses, like, the function f of x. If you're looking at a graph of this function, you see it crosses the x-axis one time. This tells you it crosses it only once, no matter how far you zoom out on that function. Like, you know, no matter what you do, it's never, ever going to turn around and cross again. Does that idea make sense? So if you were, say, trying to solve something like that for some whatever reason, you'd be able to say without a doubt that, yes, for sure, this is only 0 one time and not some other time that we can't see. That's how you prove it. If you want to be a lawyer, take lots of math classes, because the logic in math classes is like everything that's on the LSAT. So.
So why did you pick f of 0 and f of -1?
I just chose a number such that when I plug it in, I get a positive, and one where I plug it in and I get a negative. So 0 and -1 aren't special, they're just the closest together whole numbers I could find. But you also could have chosen like 1 and -2, I think would have also worked. So there are lots of right answers here, and as long as one result is positive and one result is negative, that's all you need. Does that make sense? Does that help? Okay. Yep, so those numbers are completely up to you. I just like to choose 0 because 0 is easy to plug in. Yes? And then, you know, the ones are also easy to plug in as well, so I just pick things that are kind of small-ish. Okay. Now here's another, this is the same theorem, just not a special case. So look at the first two hypotheses. They're almost the exact same, right? Dane, you still alive? Okay, good. What's missing?
They don't have to equal each other.
Yeah, the endpoints are not necessarily equal. And this says there is a number c in the interval a to b such that the derivative equals this. And heck, isn't that the average rate of change? Do you see what I'm saying? This thing says the slope of the tangent line must equal the slope of the secant line somewhere. Here's the picture of what that looks like. So you take away equality at the endpoints, do something like this. that's the slope of the secant line, right? That's the m equals f of b minus f of a over b minus a. This says your derivative somewhere in there has to have the same m. I think this one makes the most sense in terms of a physical situation. So f prime of c, that could be your velocity at time equals c, equals your average rate of change. So for example, if I went to Anchorage and my average rate of change was 60 miles per hour, like I was able to average that including going through some places where the speed limit is slow and there are stoplights, what this says is I had to be going 60 miles an hour at some point in time within that interval. Sometimes over, sometimes under, but I had to go 60 at some point in time. My instantaneous, which is fluctuating a lot, right, has to be 60 somewhere within the interval, maybe more than once. Okay. And then the last thing I want to say before we deal with this a little bit is that this is the same as Rolles Theorem. Okay, so add in condition 3. If f of a equals f of b, then what is f of b minus f of a equal to? 0. And f prime of c will equal 0 over b minus a, which is 0. That's what it means to be a special case of something. So that third condition, you still have the same conclusion, right? So the slope of the tangent, the secant line happened to be 0. Does that make sense? Okay. So verify that this function satisfies the hypotheses. So what are the hypotheses for this function? It must be just two things. Continuous where? So on -2 to 3, is that what I gave you? Did I change your interval? Since, and what else has to be true? Since f of x is a polynomial. Now we want to find where f prime of x equals f of b minus f of a over b minus a. And the difference here is you're going to set the derivative equal to some number that's not necessarily 0. It's just going to say, where is the slope of the tangent line? I don't know, 2 or something, instead of where is the slope of the tangent line 0. Okay? So what goes in for A and B in this case? What goes in for B? 3. What goes in for A? That's it. Yep. So f of 3 minus f of -2 over 3 minus -2. And what's f prime of x?
3x cubed minus 2.
Almost 3x squared minus 2. Okay, so you're solving 3x squared minus 2 equals, okay, well that's all over 5, yes? So what do you get with this thing when you plug in 3? You get 27 minus 6 plus 1 minus -8 plus 4 plus 1.
That's 22 minus -5?
Do you guys agree?
No.
I think minus -3.
-3, yeah.
So 22 plus 3 over 5. That works out nicely then, doesn't it? So 3x squared minus 2 is going to equal 5, I believe. Can you solve that? But see, the difference is derivative equal to slope of secant line, right? As opposed to being 0. We've done stuff like this. It's just we've always done it where we set the derivative equal to 0, right? Okay, so that'd be 3x squared equals 7. X squared equals 7/3, and x equals positive or negative root 7/3. I believe those are both within the interval. 7/3 is awfully close to 6/3 or 2. And root 2 is within positive, negative root 2 are both within that interval. If you want to rationalize the denominator, you could say plus or minus, that's root 7 over root 3, which is plus or minus root 21 over 3.
Regardless of the fraction, root 7 itself is still less than 3.
Yep, but the point is, if you put it into WebAssign, make sure it's obvious that the 3 is also being rooted. Does that make sense? Otherwise, it will tell you that you're wrong. I don't think it makes you rationalize denominators, does it? No, isn't that nice? Okay. There you go.
Accepts both answers, that's nice.
Mm-hmm. Yay. All right. So the thing that'll be on your quiz probably is something like this, really. Like, find the numbers that satisfy the conclusion. I haven't decided if I'll put anything like the prove there's 1 0 on there, but probably not. It's just a bit tricky. Okay. So suppose you've got a continuous function on 2 to 5. You know that the derivative is in between 1 and 4. Show that f of 5 minus f of 2 is in between 3 and 12. Well, so since f prime exists,
We just multiply by 3.
kind of, you know f is differentiable, and differentiable implies continuous as well. If you have a derivative existing, you have to be continuous. And so by the mean value theorem, you know that f prime of x equals, so you have this interval from 2 to 5, right? That's equal to f of 5 minus f of 2 over 5 minus 2. Does that make sense? And I chose the interval from 2 to 5 because I was told interval 2 to 5, right? That's I was given that information. The other hint is that these numbers are 5 and 2, so you kind of care about what happens between 5 and 2. Okay, so since 1 is less than or equal to f prime of x, which is less than or equal to 4, can't I plug in that f of 5 minus f of 2 over 3? And then are you going to get the thing you're supposed to how do you get the thing you're supposed to show? Multiply by 3. We've got 3 is less than or equal to f of 5 minus f of 2, which is less than or equal to 12. So what that tells you is that the difference between your last and your first y value is between 3 and 12. So no more than that. I guess it also means, yeah, it also means that f of 5 has to be bigger than f of 2, doesn't it? Because for that difference to be positive, so f of 5 must be at least 3 units above f of 2. And I should have, I mean, when I saw these problems when I was in Calculus 1, I'm like, gosh, it looks so much like the theorem we were almost given, right? It's just the numerator only. Okay. And another thing that you can do, you can take a picture of it? Yes. You're good? Okay. Now here's another thing. So if you know some information about the function's value at a point, and then you know the derivative is always less than or equal to 5, you can use this to determine how large certain values can be, like the biggest possibility. Okay, so here's how you do that. You know that since f prime exists, f is differentiable and continuous. What you need is an interval. And the problem gives you a hint as to what to choose. So which x value do you know something about? 0. What x value do you want to know something about? 2. So look at the interval from 0 to 2 with the mean value theorem. And much like we abbreviated the intermediate value theorem with IVT, this one we're going to call MVT, mean value theorem. Okay.
But wouldn't you also do the less than 5?
We'll get to that in a second. Yep, so we're gonna use that information later on, but the first thing is you look at the mean value theorem on this with this stuff. So then you know that f prime of x is gonna equal f of 2 minus f of 0 over 2 minus 0. That's the MVT statement, right? Just with 2 and 0 plugged in for a and b, right? So MVT with a equals 0, b equals 2. Or aren't you given some more information? You're told something about f of 0, aren't you? What's f of 0 equal to? So that's going to be f of 2 plus 3 over 2. And that's since f of 0 equals negative 3. Okay, and now you also know, here's where you're going to use that last part, you know f prime of x is less than or equal to 5, right? So doesn't that mean that f of 2 plus 3 over 2 is also less than or equal to 5? Because those two things are equal, right? So if f prime is less than or equal to 5, then so is f of 2 plus 3 over 2, right? And now can you sort of get f of 2 by itself? What would you do first? So f of 2 plus 3 is less than or equal to 10, right? So f of 2 is less than or equal to 7. And that means f of 2 is at most 7. So the largest y value you could get when plugging in 2 is 7. Nothing bigger can happen. But the tricky thing with that I think, at least I didn't see when I first did these problems, was that you have to pull the interval out of the x values you're given information about. Does that make sense? Like you pull the interval based on the thing you know something about, and they have to give you that, and then the thing you want to know something about. Okay. I think this is a really cool question. So 2 patrol cars have radar, and they're 5 miles apart on a highway. A truck passes, as the truck goes past the first cop, his speed is 55 miles an hour. And 4 minutes later, when the truck passes the second patrol car, its speed is 50 miles per hour. Can you prove that the truck was speeding or not speeding during the interval? So we're going to show that this truck had to speed, in part because he went too fast between those 4 miles. Okay, so what we're going to do is we're going to let f of t be the car's position.
This is like when the shadow government has.
So when the government outmaths you and gives you a ticket, okay?
See, right?
F of t be the car's position from, we'll call it cop number 1, okay? So then, does it make sense that f of 0 equals 0, like its position after 0 minutes is 0, distance 0, whatever's past that cop? Now, the one funky thing is that 4 minutes later. So how much of an hour is 4 minutes?
Wouldn't the initial, because it's starting at 55, like
That's its initial speed, not its position. But if you just think about, okay, well, here was cop 1, there was cop 2, what is his distance from cop 1 to cop 2? So his distance from cop 1 is, when you start, he's 0 miles from cop 1. When he ends, he's 5 miles away, right? Okay. So at what time is this guy 5 miles from cop 1?
1/8 of an hour.
4 out of 60, which is 1/15. Okay. So then by the mean value theorem, the derivative has to equal f of 1/15 minus f of 0 over 1/15 minus 0. So what's f of 1/15? 5. And f of 0 is 0. What is 5 divided by 1/15? Big number, small number? Specifically 75. And so thus, the car's average speed, or truck, because, you know, trucks are the ones who speed. No offense, guys, that's why your insurance is higher. Thus, the truck must have been going 75 miles per hour.
And we know that 60 miles per hour is a mile a minute, and
Mhm.
if it's 5 miles in 4 minutes, it had to be going more than a mile a minute.
Yep, exactly. But I just use math to give you a ticket.
They couldn't give them a ticket for that, though, could they?
I'm not sure. I think they could.
I think they have to
Sorry,
watch the
they
clock
check your
going
log
that
books.
fast, though.
I don't know if they do. I think that the rules are different in different places.
That's the whole reason why they
But
have
then I
to.
think they would put
They
that
have
much
to
effort
actually-
into it.
No, but it really isn't very hard to do, you know, position. They're not going to write down a proof of it, right? This is math class. But they could figure out your change in position divided by change. It's just change in position divided by change in time, right? So it's just how much did you travel over how long did it take you? And as long as they do the correct unit conversion with the minutes, making it into hours, they know your miles per hour and they know that it was greater than the speed limit, and yes, then they can give you a ticket.
So they check.
Pretty sure they have to like record you.
I think it's
based-
different in different
basing-
states, and it's not worth arguing over, because it's not something we have, like, we don't have time to look it up, and it's not worth our time right now. Yes.
So you just simplified the 4 over 60 to 1/15.
Say that again?
You simplified the 4 over 60 to 1/15.
Yes, I just reduced it. Divide the top and bottom by 4, you get 1/15. Yep. Okay. Now, last thing on this lesson, and we'll take a move on when this is done. So show that there is no value of c in 0, 2 such that this happens. And then why does this not contradict Rolles' theorem? So what does absolute value x minus 1 look like on the interval from 0 to 2? What does its graph look like?
What's the absolute value of x shifted to the right 1 units?
Uh-huh. So there's 1. It's a v. Okay. On the interval from 0 to 2, does it make sense that f prime of x is equal to 2 things? It's -1 if x is in between what 2 numbers? So look at that picture. When is the slope -1? Between what two values? 0 and 1. And when is the slope +1? If x is between 1 and 2. And so thus f prime of x is not equal to 0 ever. And actually, I kind of jumped a gun there. If you do this expression, you do f of 2 minus f of 0 over 2 minus 0, that's going to equal 1 minus 1 over 2, right? Because when you plug in 2, you get 1, plug in 0, you get 1. So why is this not a contradiction? So you said, okay, well, you know, the derivative is 0, the function's continuous, but the derivative isn't 0 in between those two numbers. Why is it not a problem?
You just meant to put this not equals them.
Yes, I did. Okay, so why is this not a contradiction? What is missing here? It's not a contradiction because what has to be true to use Rolles' theorem?
There has to be a zero slope somewhere.
Nope, there are three things that must be met, and then there'll be a zero slope. It has to be continuous, differentiable. Is this differentiable? No. So it's not a contradiction because f of x is not differentiable on the interval from 0 to 2. And they say due to the corner at x equals 1. So it doesn't contradict Rolles' theorem because one of the conditions isn't met. The condition that your function be differentiable everywhere in the interval. What? Yes?
Would you have to do all the wordy proof stuff, or could you just say that right from the beginning? Because you know it's an absolute value, it's not differentiable.
You'd have to tell me what the derivative was. Okay, you gotta give me some example that you understand that, okay, the derivative is either this number or this number. So yes, you have to do something like this. You can say this in different ways, but you'd have to say that somehow. You could say it was -1 for up until 1, and then derivative is 1 on after 1. But you got to tell me that you understand the derivative is not 0 at all. Okay. Now this one. Okay. Show that there is no value of c where the derivative is equal to, in this case, same thing. So f prime of c equals, what is f of 2? In this case, for this function. Okay, 1, f of 2 is 1. What's f of 0? I think it's also 1. So we're going to show there is no c where f prime of c equals 0. So find f prime of x. So this is the same thing as x minus 1 to the -2nd. So what's the derivative of that function?
-2
Mm-hmm.
over x minus 1 to the 3rd.
Mm-hmm.
So where did you find f of 2?
Say that again?
What did you do for f of 2?
I still couldn't hear you, sorry.
Where did you find f of 2 again? And then the second step?
How did I find f of 2?
Yeah.
When you plug 2 into this function,
Okay.
you get 1 over 2 minus 1 squared.
Okay.
And 2 minus 1 is 1, 1 squared is 1. Okay, so you're supposed to show there's no value for this at which this happens. You try to solve this thing equal to 0, and
X minus 1 to the 3rd.
doesn't matter, but yes. And so what's going to happen when we try solving this? You multiply by the denominator, and then what happens? You get 0 equals -2, and when weird crap like that happens, this means what? It does 0 equal -2. Got no. That means that there's, it means there's no solution, right? It means that that's never gonna happen. Why does this not contradict Rolles' theorem? As what's not true about f of x? What's the what of the three hypotheses with Rolles' theorem didn't happen here?
It's not continuous.
It's not continuous. And where? At what number?
After one,
At 1.
yeah.
At x equals 1, or something equals 1, right? Some number equals 1. So the point is that if you try to apply Rolles' theorem to something for which one of those three things doesn't happen, then the theorem doesn't work. Okay, so that's it for that lesson.